All right, class. Today we're going to get into solving equations. You'll hear the word isolating variables throughout the day. We'll go over what that means. We're going to isolate variables and apply inverse operations to both sides of an equation. Before we begin, I'm going to go and hand out some board work. Okay, I'd like you to complete this on your own, showing the work on this paper. And when you've completed that, we're going to go ahead and turn to Chapter 5, Lesson 4 in our pre-algebra books. So go ahead and go through that, and remember PEMDAS when you're completing these order of operations questions. So this is right here. Good, make sure we're showing our work. James, nice, good work. Good. Nice, good job, guys. Keep it up. Grace, make sure you put the sheets. All right, awesome. Looks like we're almost done. As you finish up that last problem, get ready to be prepared for me to collect it. And you can turn to page 132 in your book. All right, I'm going to start collecting. Looks like everyone's good to go. Just finish up that last problem you're on. Good. That's good. So, thank you. Awesome. Thanks, Grace. Awesome. Good job, Maddie. Perfect. All right, thank you, guys. All right, then we'll go ahead and open up page 132. Solving equations is our chapter that we're on. Awesome. As we're returning to that, I just wanted to kind of give a little overview today. We're going to present a method for solving equations using inverse operations. Okay? Really quickly, can someone tell me, raise your hand and tell me what our 4 major operations are that we do in math? Go ahead and give me one, Grace. Multiplication's one. James?
Division.
Division is another one. Tyler?
Addition.
Addition and
Subtraction.
subtraction. Good. Now, as we know from PEMDAS, multiplication and division, they go together and they are inverses of one another. Okay, meaning that they're opposite. Therefore, addition and subtraction are also inverse of one another. Okay? So when I say the words inverse operations, I'm referring to the opposite method used for the order of operation. Okay? We also have variables. Okay? Variables are unknown numbers that are described using letters, okay, like an X or a Y. And you'll also talk about constants within equations. Those will be numbers that are usually whole numbers that you'll see in equations when we set them up, okay? So, inverse operation. It's an operation that undoes another operation. That undoes another operation, that undoes another operation. Okay? Our objective today is to isolate variables by applying inverse operations to both sides of an equation. So today you will be responsible for solving equations by isolating variables and applying inverse operations to both sides of an equation. Okay? We're going to go ahead and look at our first example. Okay? Remember, we're going to solve using inverse operations. So be thinking about opposites as we begin. Okay? Are we all on that page? Perfect. All right, so our first example. Okay, can someone tell me what this says? Read it for me, Maddie.
So, plus 1 equals 3.
Okay, what's key here is we're going to solve for x. We want to know what x is equal to. X is our what again? What do we call x? Our
Variable.
x is our variable. Okay, we do not know what x is right now. Do we know what x is? Not right now. What do we call this number? Okay, I kind of said it earlier. Ty? This is our constant, okay? What we're going to work on is getting x to be by itself or isolating the variable and figuring out what it is. So, James, what operation do you see here?
Add.
Addition.
Addition.
Plus 1. What is the inverse operation of addition? Maddie? Subtraction. So guess what we're going to subtract? We're going to subtract 1. That is correct. Rule. If you do an inverse operation on one side, you have to do it to the
Other side.
other side. That is correct. So if we subtract 1 from this side, we have to subtract 1 from here. Imagine that there's a little line going through here, I guess. Okay. Subtract, here you go, so step 1. Subtract 1 from each side of the equation. And we have that set up here. What is 1 minus 1? Anybody? Grace? 0. It cancels it out. So x plus 0 really means x. What's 3 minus 1? James?
2.
So we perform the operation, which is what we just did, and what do we find out? Maddie?
X equals 2.
X equals 2. Now, what's really key here is when you're showing your work on your during these problems, is to step 3, and we can't forget this, is to check by substituting your answer into the equation. So, Maddie Hart just said x equals 2. Thumbs up if we agree, thumbs down if we don't. Everyone agrees? Let's check. X plus 1 equals 3. Okay, this is what they mean by check by substituting. Sophia, what does she say x is equal to?
2.
So, does x plus 1 equal 3? Let's see. Does 2 plus 1 equal 3? Thumbs up if you agree, thumbs down if you don't. Perfect. This is correct. Good job. We're going to do the next example, okay? I'm going to erase this. Our next example. Okay? Did you see how real quick before we go on, did you see how we got the variable by itself, x equals, and then they gave us the answer? We're going to do that again in this example. Okay? That second example in your chapter, what does it say? Ty?
X plus a fourth equals 3/4.
X plus 1/4 equals 3/4. All right, we have some fractions here. Remember, we are going to solve for x. What do we call x again? What is x? It's a
Variable.
variable. I could say y. I could say z. These are variables. They're unknown numbers. In this equation, what does 1/4 represent? Ty? Our constant. Grace, is our variable isolated right now? What do we have to do to isolate it?
We have to do 1/4 plus 1.
We have to get rid of 1/4.
Yes.
Okay, now, Sophia, what operation is this?
Addition.
What's the inverse operation of addition, Maddie?
Subtraction.
So we have to subtract. What are we going to subtract from 1/4 to make it non-existent, to make it 0? James?
1/4.
Beautiful. Because 1/4 minus 1/4 is 0, and that means x would be by itself. What's the rule, though? If you subtract from one side of the equation, you have to do what, Grace?
You have to put on the other
You have to subtract from the other side.
yeah.
Perfect. So, what's 3/4 minus 1/4? Ty?
2/4.
Okay, so we have 2/4. What's 1/4 minus 1/4?
0.
0. So guys, because this equals 0, we don't need to have it say x plus 0. What that really means is just x equals. What do we have? So?
X equals 2/4.
Perfect. Now, it's already at 2/4. Let's check it, okay? Before we don't need to reduce it because 2/4 is equal to 1/2. But we're going to check this, okay, using 2/4. Okay. What did we say x is equal to? Maddie?
2/4.
Let's check this. X plus 1/4 equals 3/4. So, you isolated the variable, you found out that it was 2/4, we plug it in. You put 2/4 into x, you make 2/4 x. Okay. Do we have common denominators? Yes or no? Thumbs up if we do. Beautiful, we do. So we can just go right across. What's 2 plus 1?
3.
And the denominator comes along for the ride. What's the denominator, Sophia?
4.
Does this equal this? Checked. It's been checked. It is correct. Great job. So, what do we call this? Maddie? Our variable. What do we call this, Sophia? The constant. We want to get rid of the constant and isolate the variable so it's by itself. Okay, great job. In our handout today, I'm going to hand out to you guys, we're going to continue doing this solving for equations. Okay, go ahead and put your name and date on this. This is period 2. And you can keep your book open to the chapter if you want to go over the notes. We're going to look over this together. Awesome, go ahead and put your name and date on that. And as you're doing that, I just want to go back and say, you guys just solved equations by isolating the variable and applying inverse operations to both sides of the equation. If you get a multiplication problem, what's the inverse operation, Michael?
Division.
Thank you. If you get an addition problem, it's subtraction. If there's a subtraction problem, it's addition. If there's a division problem, it's multiplication. Okay? Remember the order of operations. Those are the four key operations when we're doing this. Okay. Sophia, what's the first problem on our worksheet?
26 equals
26 equals
8 plus
8 plus v. Okay, what is our variable? Grace?
B.
Perfect, v is our variable. So in this problem, we want to solve for v. We want to know what v is. That's our variable. What's our constant? James?
The 8.
Beautiful. The 8's our constant. Okay. 26 equals 8 plus v. If we really needed to, we could flip it around. We don't have to. We need to get what part alone? Isolated. We need to completely isolate it. Which one? What are we isolating?
V.
V, our variable. Okay? How do we do that? What's our first step? So?
Minus 8.
Beautiful. We are going to subtract 8 from this side. 8 minus 8 is 0. So that will give us v by itself. What are we forgetting to do? What's our rule, James?
Minus the other side, like 26 minus 8.
Thank you. Whatever you do to one side, you have to do to the other. Can someone tell me what 26 minus 8 equals? 18. 18 equals v. Are we done yet? No, correct. Step 3. Substitute our number in the equation. So, how would we set this up? Ty.
26 equals 8 plus
Everybody, on your calculators, do 8 plus 18. Show me what you've got. That's correct. 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 Correct and correct. Beautiful. So guys, on your worksheet you have 18 equals v. And go ahead and circle it for me, and you've checked it, okay? The check is important, because if it doesn't make sense when you go back and check it, you know you've done one of the steps incorrectly, okay? Everyone has that written down. Beautiful. All right, I'm going to need a volunteer to come up, and we're going to have them do number 2. Real quick before I do that, what is number 2?
3 plus p equals
3 plus p equals 8. Okay, remember, we are solving for p. All right, who wants to come up and give it a try? Give it a whirl here. All right, Ty, nice and slow. Go through it with everyone. And everyone should be following along on their worksheet. Step 1, Ty.
Alright, step 1 is we have to get the variable by itself.
And that means isolating the variable. That is correct.
So we have to subtract 3 from each side.
All right. So what's 3 minus 3?
0.
So that means we've got p by itself. Beautiful. Grace, will you tell Tyler what 8 minus 3 is?
5.
ahead and make an equal sign.
So, since we isolated the variable and solved a minus 3, equals 5.
Perfect. What is our last step though to make sure?
Plug in 5 and
Can you do that on the right? Go ahead and do it in a different color.
3. Okay.
Everyone, what does 3 plus 5 equal?
8.
Do we agree? Thumbs up if we agree, thumbs down if we don't. Maddie, Grace, thumbs up, good. It's been checked. That is correct. Awesome, thank you, Ty. So, did we all get P equals 5 for 2? We should have completed that, wrote it down, good. Good, P equals 5, right below it, circled. Good job, Ty. Change, good work. Circle that P equals 5. I love that you checked that, by the way. That was a great job. Make sure you're checking those. Awesome. All right, before we finish, remember, your learning target today was to solve equations by isolating variables and applying the inverse operations to both sides of an equation, okay? Before I let you guys go ahead and complete the rest of the worksheet, I need you guys to go ahead and give me a rating here. Give me a 0 if you have no understanding of what we were just talking about. Give me a 1 if you have no idea what we're doing, what we're working on. Give me a 2 if you think if you're trying real hard and you're just not understanding this concept. Give me a 3 if you think you understand how to solve equations by isolating variables. And give me a 4 if you feel comfortable working on this independently and could teach the class how to solve equations by isolating variables and applying inverse operations to both sides of an equation. Beautiful. To end, I'd like you to independently work on questions 3 through 6. Let me know when you're done and I'll come check them. And if we've completed them independently, you can continue on for the rest of the period. All right, go ahead and begin.